Okay, so this is page 2 of lesson 1.4. We're still talking about subtracting rational numbers. This is another way to think of subtracting rational numbers is it's really the same thing as adding the opposite. So I want you guys to think of a really easy example. If I have 5 minus a negative 3, if I start at 5 on a number line and I move, remember when we're subtracting a negative number, you are going to go to the right. So if I started at 5 and I went 3 to the right, where would I end up? At 8, right? So if subtracting a negative, I'm going to put this in parentheses so you can tell the negative part from the subtraction sign. That's the only reason I separated it. If I added the opposite, 5 plus, what's the opposite of negative 3? Positive 3. What's 5 plus 3? It's still 8. So that's why subtracting a negative is the same thing as adding the opposite. We're going to start out by looking at a number line. So this example says Joe is diving 2.5 feet below sea level. He decides to descend 7.5 more feet. How many feet below sea level is he? So we're going to start at negative 2.5, which is right between negative 2 and negative 3. And we are going to move to the left because we're subtracting a positive 7.5. So that would be 1, 2, 3, 4, 5, 6, 7.5 would actually end up right at negative 10. So when we move 7.5 units, there's that absolute value again. We're moving to the left because we are subtracting a positive number. You need to fill in these blanks with me. The result is negative 10. So Joe is 10 feet below sea level. We are going to use a number line to find each difference or sum on example A and B in number 8. If I am at negative 3 on the number line, we're here, put a dot, graph that, and I subtract a positive 3, that means I'm going to move to the left 3 times. 1, 2, 3. Where do I end up? Negative 6. That's what you need to write there. On example B, if I'm at negative 3 and I add the opposite of what was up here, I'm adding, what's the opposite of positive 3? Negative 3. So if I'm here and I add a negative 3, 1, 2, 3, I still end up at what answer? Negative 6. Notice they're the same. So subtracting a rational number is the same thing as adding the opposite. So instead of always using a number line, we're going to talk about something else we use in our math classes to make it a little easier, because we don't expect you to draw number lines for every single problem. We just say to keep it, change it, change it. Okay? I want you guys to write this out with me. What this means is the keep it, underline the K. Keep it means keep the sign of the first integer, or the first rational number. Okay, the C, the first change it, underline the C. The first change it means change subtraction to addition. And the third C, underline that C, that stands for change, means change the sign of the second integer. So if you can remember these rules, I'm going to put little bullets here. Keep the sign of the first integer, change subtraction to addition, change the sign of the second integer. If you can keep those rules, oh, I'm sorry, I wasn't showing you what I was writing. Remember, you can always rewind if you didn't catch something I said. Okay, so if you keep these rules straight, you should be able to solve any subtraction of rational numbers or any subtraction of integer problems. So let's practice this. If I do keep it, change it on this example right here, I'm going to write KCC in my little grid. Okay, keep it means I'm going to keep the sign of the first integer. Well, the first integer is -2.5. I'm going to keep it that way. The first C means change subtraction to addition. So I'm going to change this subtraction sign to an addition sign. And the last C means change the sign of the second integer. So it was a +7.5, but now I'm going to make it a -7.5. Well, in the last lesson, Miss Joyce taught you that when you have the same sign, you can add them. So what's a -2 plus a -7? That's a -9. But then we have a half and a half. So a -1/2 plus another -1/2 is another whole. So what's -9 plus another negative whole? That would be a total of -10. Okay, let's try another one. If I use keep it, change it, I want to go ahead and write that in my little grid, my little chart. Keep the sign of the first integer, that -3 stays the same. Change subtraction to addition, and change the sign of the second integer. It is a +3 right now. I'm going to change it to a -3. So again, what you learned in the last lesson, I have the same sign, so can I add them? Yes. What's a -3 plus a -3 equals a -6. So that's a much easier way, I think, than using number lines. So very important. We will go over this a lot again and again till you guys get it. Okay, so on the last section, this time we are finding the distance between two numbers. The example says a cave explorer climbed from an elevation of -11 meters to an elevation of -5 meters. What vertical distance did the explorer climb? So there's two ways to find the vertical distance. A says you can start at -11, and we can plot our point down here at -11. We can count the number of units on the vertical line up to -5. So I can go 1, 2, 3, 4, 5 right here. And that means the explorer climbed 6 meters. This means that the vertical distance between -11 and -5 is 6 meters. Okay, so that's one way we could do it using, again, a vertical number line. B says we can find the difference between the two elevations and use the absolute value to find the distance. So -11 minus a -5, I want you guys to, again, remember the rules I just taught you. This is what you would do on homework. I would draw the chart and I would say keep it, change it. I would say I'm going to keep the -11. I'm going to change the subtraction to addition, and I'm going to change the -5 to a +5. I was writing a 6, a 5. Okay, so I have a negative and a positive. Can I add them? No. Different signs, you end up subtracting. So what's 11 minus 5? That's 6. And then you take the sign of the larger number, so that would actually be a -6. But that's why it tells you to use absolute value, because remember, we're talking about distance, vertical distance. So we're taking the absolute value of -6 because distance cannot be negative. The vertical distance is actually 6 meters. So that's how you would do that. Again, if you are confused at all, if you have any questions about this lesson, please remember your questions, write them in the margin. We will talk more about this in class, and we will do plenty of examples till you all feel comfortable.